let's look at some examples of what we can do with Pythagorean identities. So first, suppose we are told that sine squared of theta is equal to 0.4 and asked to find cosine squared of theta. Well, remember that because sine squared theta plus cos squared theta equals 1, we can rearrange this and see that cos squared theta is equal to 1 minus sine squared theta. And since we were told that sine squared theta was 0.4, we get 1 minus 0.4, which is 0.6. So that's what cos squared theta would be. Now, if tan squared theta is equal to 3, find secant squared theta. Well, here we're going to use one of the other identities, which is, remember how we get this is by dividing this equation, or this identity, by cos squared. The identity we get is tan squared theta plus 1 is equal to secant squared theta. And so here we can just plug in 3 for tan squared and add 1 and we'll get secant squared. So secant squared theta is equal to 3 plus 1, which is 4. So that's secant squared theta. Now here's another idea, another type of problem that we can solve. So here's another type of problem we can solve. We don't know what 34 degrees, or sine of 34, or cos of 34 degrees is, but because of this identity, we know that sine squared of an angle plus cos squared of that same angle is equal to 1, right? That was the identity we saw. Sine squared plus cos squared is equal to 1. So we know that this just simplifies to 1. And now we can dress these up in a little bit of a different way. So if we were asked what is secant squared of pi over 7 minus tan squared of pi over 7, this doesn't immediately look like one of the identities we know. But let's think about how we can rearrange the identity that we've seen before. So if tan squared theta, or in this case pi over 7 plus 1, is equal to secant squared of pi over 7. Well, rearranging then, we want to subtract tan squared from both sides. So this would tell us that secant squared of pi over 7 minus tan squared of pi over 7 would be equal to 1. So this would be just an equivalent way of writing our original identity. Just by rearranging it a little bit, we find that secant squared minus tan squared is equal to 1. Now, we're asked to find what cosecant squared of 102 degrees minus cotangent squared of 102 degrees is. And so here, we need to remember our other identity, which is that 1 plus cotangent squared of theta, for any theta, is equal to cosecant squared of theta. And so if we rearrange this a little bit, we would subtract cotangent squared from both sides. We find that cosecant squared of theta minus cotangent squared of theta is equal to 1. Again, all we did was subtract cotangent squared of theta from both sides of the equation. So this would be another identity, another equivalent version of our Pythagorean identity for cosecant and cotangent. So in this case, cosecant squared of 102 degrees minus cotangent squared of 102 degrees would just be equal to 1.